In today's video, we're going to look at questions involving limits as x approaches infinity. And this question here is from the JEE Main, April 2023, Shift 1. This rather horrific looking expression, we have to work out what the limit is as x approaches infinity, and we're given four options: 15, 9, 18 or 24. Okay, now the main problem with this is that if we look at this expression here, log to the base e 2x add 1 to the power of 5, as x approaches 0, that approaches 0, and also that approaches 0, and incidentally that also approaches 0. So we got lots of 0 over zeros, and with 0 over zeros we cannot establish what the limit is. So what we need to do is we need to get all of these in terms of let's just get rid of that because we'll use this space later. We need to get rid of all of these in terms of something which does not go towards 0 as x goes towards 0. And so what we're going to do, there's about 6 of these things. So let's have a look at the first one. The limit of sine x over x as x approaches 0 is 1. And you just have to learn these, you just have to know them. This comes from the Maclaurin series, sine x equals x minus x cubed over 3 factorial add and as x approaches 0 that becomes increasingly small, and that's what that comes from. And this next one here, the cos one, is a limit of x approaches 0, 1 minus cos x over x squared approaches a half as x approaches 0. Again, that's from the Maclaurin series, cos x equals 1 minus x squared over 2 factorial add x to the 4 over 4 factorial That gets increasingly small, and that basically is that. And the third one here, again from the Maclaurin series, that log of 1 plus x expansion is x minus x squared over 2 add and that becomes increasingly small, and so that gives us that. Let's just have a look at another 3, these ones. The limit of cos x as x approaches 0 is 1. Now these two aren't very useful. The limit, not in this question anyway, the limit of sine x as x approaches 0 is 0, and the limit of tan x as x approaches 0 is 0. And I've added that one because in the question you might be tempted to turn sine cubed 4x over cos cubed 4x into tan cubed 4x, but that's the worst thing you can do because tan cubed 4x also approaches 0, and we're left with even more 0 over 0 problems. So we certainly don't want to be doing that. One other thing, this is 4x and this is 3x and log is 2x. Just on these things, so basically if we add a 4 there, that is still valid. The limit of sine 4x over 4x as x approaches 0 is 1. On cos x we can add 3, so that would be the limit of 1 minus cos 3x over brackets 3x squared is a half. On this one we can add a 2 here, and it's still a valid limit. And of course on the final one, the cos one, what was the cos here? 4x. So again, if the limit of cos x is 1, well the limit of cos of 4x is also 1. Okay, so what we need to do is we need to use these limits on this expression, and we're going to go through them one by one. So alright, so first of all let's have a look at this 1 minus cos squared 3x. So let's have a look at that one here. So 1 minus cos squared of 3x, well that equals 1 by the difference of squares, 1 minus cos 3x times by 1 plus cos of 3x. Okay, and we need to get these things into this form. Well, 1 plus cos 3x as x approaches 0, cos of 3x approaches 1, so that bit there approaches 2. So it only leaves us with this bit here, and this is almost in the right form here, but what we have to do is we have to multiply top and bottom by 3x squared, so that would be 3x squared over 3x squared times 1 minus cos 3x times by the 2, which is that limit, and 1 minus cos 3x over 3x squared, this bit here, by this limit here, is a half. So that will give us this 3x squared times a half times 2. That's what this will become in the limit. Okay, let's have a look at the next one. Well, that one there clearly just comes to 1 because cos of 0 is 1. Let's have a look at sine cubed 4x. Sine cubed 4x, let's have a look here. So basically we have sine cubed of 4x. Well, we need to, no, sorry, not that one, is it? It's this one here, my apologies. Sine cubed 4x. So we have sine cubed 4x, we need to get it in the form sine x over x. So let's divide by 4x cubed and multiply by 4x cubed. And then this bit here, we know by this will be equal to 1 cubed times 4x cubed, which clearly is 1 times 4x cubed. So that's 4x cubed there. Okay, and let's have a look at the next one, which is here, log to the base e, 2x plus 1 to the 5. That is this one, so that's a log to the base e of 2x plus 1 all to the power of 5. Well, again, what we need to do is to get it into this form here, we need to divide by 2x to the power of 5 and multiply by 2x to the power of 5. And then this bit here will approach 1, because that becomes log of 2x plus 1 over 2x to the power of 5. That will become 1 to the 5 times 2x to the 5, which is equal to 2x to the 5. Okay, so what we've done is we've taken each of the bits and we've turned them, and now all we've got to do is we've got to put all of these back into here. Okay, so let's just clear a little bit of space here, because all we're going to do is we've worked out what all of these come to as we approach 0, and then we can work out what the answer is. So let's just clear all that there. Okay, good. Right, so now let's go back into the pen, and what did we work out? So we worked out that this one here, 1 minus cos squared of 3x, what did that come to? Came to 3x squared times a half times 2, so that's 3x to the power of 2. And cos cubed 4x, we worked out, came to 1. And sine cubed 4x, we worked out here was 4x cubed. And this one here, we worked out was 2x to the 5. That'll be over 2x to the 5. And so that basically gives us 3x squared times 4x cubed over 2x to the 5, and we need the limit as x approaches 0 of that. Well, fortunately for us, the x's cancel out, and it leaves us with 3 squared times 4 cubed over 2 to the power of 5. Well, 3 squared is 9, 4 cubed is 64, and 2 to the 5 is 32, which equals 18, which equals option 3. And so option 3 is your answer. I hope you found this useful. Basically, even though they do look rather scary, if you take each one of them one by one and try and convert it into a form which does not approach 0 or infinity or whatever, depending on what the question is, so you don't get these 0 over 0 indeterminate forms, then this is how you'd answer it. If you've liked this, then please press the little thumbs up button and subscribe to the Grassy Academy YouTube channel. Thank you.